Recorded. Everyone will watch it and catch up. And get a thumbs up from the back. Hey everyone, morning. So, not many of you here. I know Mads is downstairs giving a talk, so everyone's probably down there listening to that. Who wants to learn about C#, eh? My name's Clifford Agius. I'm a captain. I fly Airbus A320s around Europe. I used to fly 787. We were just talking about traveling across to a place like Seattle and stuff like that, and the views you get out the window. So it's a fantastic office view out the flight deck window. I recorded this flying across to Seattle, actually. Down there, underneath the clouds, is Greenland. I just left my phone on the side window and let it record for a bit. It's a nice, great backdrop to slides. So I'm here today to talk about, could a co-pilot, an AI co-pilot, I had to put the AI because otherwise it was a bit confusing with people, which one's which, be a real co-pilot. I'll explain which is which in a bit. A bit about me first though. My job, I fly for a major UK airline. Because this is being recorded, I can't tell you which it is, but I'm sure you can work it out. I'm also a freelance .NET developer, mainly in the Maui, Xamarin space, hence the retro t-shirt. But also IoT. I spend a lot of time doing electronics, robotics in that space as well. When I'm not doing that, I just love coding and teaching people new things, going into schools and teaching kids about electronics, getting that blinky hello world lights going, and then supporting people to do things differently. So going into companies and working with them, how they can take some of the learnings from aviation and bring them into their workspace, certainly about critical thinking. And like, obviously, family man, wife, and 3 boys, 2 dogs, so busy life. I'm also a Microsoft MVP. There's a Microsoft stand outside if you want to go and speak to anyone about any tech and you want to kind of understand the Microsoft stack. Who flew in? There's a few people that flew in. Who's flight? Well, you're obviously going to fly out, I'm assuming, to get home. If you have a fear of flying, yeah, you're not the best at being a passenger on board an aircraft. Probably isn't the talk for you. I'm going to show some aircraft in distress. So if that is you, there's no qualms. We won't giggle and laugh as you get up and leave the room. But also, if you do have a fear of flying, anyone else that isn't flying in or out today, there's a great website there, flyingwithconfidence.com, and we can help kind of combat those fears and make you understand. It's one of the safest modes of transport there is. I'm well aware that on the news at the moment, the news banners are saying about the accident in Washington. So just because it's the elephant in the room and everyone's probably thinking about it and looking at the media and stuff like that, that helicopter shouldn't have been where the helicopter was. It shouldn't have been crossing the runway where it was. It shouldn't have been black ops, i.e. all the lights off. And, military aircraft don't have a system, which we call TCAS, Traffic Collision Avoidance System, which is where planes talk to each other and say, I'm here, and if they get close to each other, it tells one to go up and one to go down. Military aircraft don't have that for obvious reasons, because if it's broadcasting where it is, you're going to know where it is and you could possibly shoot it down if that's what you're trying to do. So, we have this model called Swiss cheese model, and if all the lines in the Swiss cheese line up, then you end up with an accident on the ground. So that air traffic control shouldn't have had the helicopter there. Helicopter shouldn't have been black ops, and the fact they didn't have TCAS. So, but these things happen. It's still the safest mode of transport, but accidents do happen. We'll learn from it. There'll be an AIB investigation, or actually it'll be an FAA one, won't it, in America. And from that we'll learn, and then procedures will get changed from air traffic control, from the military, from civil aviation as well. But the aircraft landing had right of way, as the rules of the air are. But anyway, if you're scared of flying, that's a great website to visit and come sort of do a course with us and learn how to combat your fears. And also, if you do visit it and you do the course, you get 10% off your next booking. So if you're about to book it and you're not sure, it's a great way of getting a discount as well. Let's move on though. This is my office. I said I've got an office with a view that's ever changing at like 500 miles an hour. I just scream around. This is an Airbus A320 Neo. So this is my sports car of an office car. I sit on the left as captain, so you can see the rudder pedals on the left-hand side down here. So I sit down here. A joystick, because it's an Airbus, not a Boeing. So Boeings have a big control yoke, and Airbus have a joystick, which means, as an Airbus pilot, we have a table just here, so we can pull our table out, and when we're eating our dinner and our lunch, we laugh at those Boeing boys and girls. It's the fact we're eating in comfort rather than kind of trying to juggle our dinner on our knee and spill it all down ourselves. Costs about 110 million from the factory, so they're not cheap. But that's without any seats that you're going to sit on, without any of the toilets, without any of the amenities that you expect to see flight deck door backwards. So the carpets and stuff like that are all fitted by the airlines after it's delivered. So yeah, it's about 100. That's the list price of one of these aircraft. So yeah, it's the workhorse of European airlines, flying around all over Europe, anywhere sort of Keflavik kind of down to Cairo and out towards Istanbul is where I get to fly this aircraft around. Go back to long haul in a few years' time and fly around in long haul and then visit Japan and Seattle and places like that again in the future. On board this aircraft, though, took some counting, but it's about 220-ish computers, give or take a few. Might have double counted a few while I was going through, like looking at it. By computers, it was anything that is a processor running program bespoke on that processor. So it could be something that the cabin crew use that's doing the bev maker that is controlling the water coming through and making you a cup of tea or coffee, to the flight control computers, which are keeping the aircraft safe, the autopilots, etc., etc. So about 220 computers, all making trillions of decisions because they're all fast computers. We'll say it was designed in the 1980s, first flew in the late 80s, early 90s. So it's a modern-ish aircraft as aircraft go, because obviously we use technology that has been tried and tested. It's not quite 486 technology, but it's getting there. So that's the kind of aircraft and computers we're talking about on board a modern aircraft. The picture I showed you earlier was of one that's only, I think it's about a year old. So it's fairly new off the production line. Yet it's still using computers and technology from kind of 1990s-ish. Let's talk about these computers then. What do they do? Just in case you know nothing about aircraft. Next time you look out the wing, you'll say, oh, I know what that is because Cliff told me. The flaps and slats, everyone knows what the flaps are, or most people do anyway. It's the bit at the back of the wing that comes out when you're taking off and landing. And the slats are the ones that come out the front, so where the front of the wing kind of leaves and goes forwards in a way to make the wing more curved. If the wing is more curved, then obviously the airflow over the top of the wing is going faster, and as it's going faster, it generates more lift and lifts up what can be an 80-90 ton aircraft with 180 people on board and all the catering and water and fuel, etc., and taking off on your summer holiday down to the Mediterranean. So that is what flaps and slats is. But we have this computer, SFCC. We love acronyms, just like in development. So an SFCC is a flaps control computer. It looks like that. So it's not quite what we're expecting to see as a computer. In the avionics bay, just below the floor, the cockpit, is where the avionics bay is, or the main one anyway. And it's just racks of computers like this. You can't quite see the front, but the front is just basically a handle and a little label that tells you who made it, Honeywell, and a handle to rack it and de-rack it. And it plugs in to the back plane of the computer. You can see all the pogo pins there. So power at the bottom and then signal at the top. This here, though, is you've got two channels. You can see the two channels, clearly identified, A and B, because that's the way Airbus like to do things. And each of those channels has got 3 processors in it. And each of those processors are running codes, and they agree the fact that we've come up with this is the answer. And if they all agree, then it's like, right, that's the answer. And then you've got channel A and channel B. We still got the right answer. Yes, we still got the right answer. Okay, right, now move to slats and flaps. So you can see there, we're already into 6. And they're all kind of controlling these these control surfaces. And obviously, when it's a control surface, which if it gets slightly wrong, i.e. the left one does it and the right one doesn't, we're going to suddenly start turning, and things are not going to be quite right. The aircraft's going to be in trouble real quick. On board this, though, we're not going to be writing .NET, obviously. We're not going to be writing kind of C and the likes. They tend to use a programming language called Ada. It's tend to using a system called SCADA, which is, see the next slide's got a bit of picture actually. It's done where they generate an engineering model of what they want that system to do, and it's all block diagrams, and then they move across from the Symlink into the specification, and they check the specification. So if we put that input in there and it goes through this box, what should we expect the output to be? They then test it and implement it, and they test it and implement it, and it keeps going back and back and back. So this is kind of what we do as developers, yeah, but we might be doing it in .NET. And we're just looking for all those green ticks on our tests and making sure they all pass. And then we pass it across to the QA team that have got a different set of tests, and they're maybe pushing buttons on the website or in the mobile app or wherever it is that you're doing. But this is all done. So before it even gets the code being generated, before any code happens, they've got the system tested and tested and tested again and made sure. And then they hand it across to a different team that test it again and QA, etc. And then once that's all done and they're happy with the design, they then can output it. In this case, this is the only kind of picture I could find on the internet that showed how the SCADA system works. In this case, they're generating C code, which then they use in, I think this was from the autopilot of a car, was what this website was, or this PDF document was showing. But in the case of aviation, they use this ADA language, which is meant to be superior and safer for generating, more fault tolerant, i.e. it will never give out an output if something happens in between and give out a false output, and it's checked. But this here is written by teams and teams of engineers that spend years and years and a lot of money to develop that one flow diagram for that one computer that sits on and just controls the slats and flaps. We've also got the ailerons, which is the left and right. We've also got the elevator, which is up and down. We've got the autopilots, should they, shouldn't they, auto land. We then got all the systems that tell us what's going on with the hydraulics, the pneumatics, the electrics. So it's all these computers that have all gone through this kind of process with teams and teams of engineers. So when the likes of Boeing are saying that they're talking about replacing their 737, which is what they're currently kind of saying to the media, they're looking to finally replace it because they've reached the end of the goal of that aircraft. The MAX 8 and 9 are kind of, there's incidents and accidents with that, which we'll talk about later. But there's a big development decision. There's a lot of money that goes into that and a lot of time. It's not something that's going to happen next week, next month, next year. It's a good 10 to 15 year development time to develop an aircraft, which is why it's taken so long. And obviously Boeing's been heavily watched by the FAA now because of all the incidents that have happened in the past and the problems they've had. We're here to talk about co-pilots, both real ones and AI ones. So I just went to Copilot on the internet and I said, how would you describe a co-pilot? An AI co-pilot is what I put in. And this is verbatim, just copy and paste what replied back to me. I'm not going to read it out, but you can tell he's talking a bit about himself. He's talking about machine learning, which is kind of old-fashioned AI. He's talking about natural language processing. He's talking about computer vision, robotics. That surprised me. I wasn't expecting that. I wasn't expecting to see robotics in there. Expert systems, which is where all that is munged together and turned into something that actually does a real-life thing. And it's saying it's revolutionising many fields at the bottom there, from healthcare and finance to entertainment and everyday consumer applications. Exciting area that continues to expand. Yeah, we all use GitHub Copilot when we're coding. We all use Copilot to ask that questions of Stack Overflow because we can't be trolling through Stack Overflow. We had a great conversation, didn't we, Denny, last night about Stack Overflow and how it's kind of, humans are not putting input in anymore. So these language models are going to be learning from no one's going into Stack Overflow and putting in a question or going in and putting an answer, and it's kind of dropping off a cliff. So what's the AI going to be trained on in the future? It's going to start eating itself, isn't it? Is the conversation we was having in the bar last night. Being an MVP, I picked the co-pilots from Microsoft. I thought to myself, how many is there? So I went onto a chat group we've got as MVPs and asked, and I got sent this great diagram that shows there's quite a lot. There's loads there. You've got all the developer ones like GitHub and Power Platform, all the business applications, which are all your finance and CRM systems, LinkedIn, Modern Work, which is all your Word and Excel and PowerPoints. Azure, there's obviously all the co-pilots on Azure as well, and Fabric. Then you've got all your browser ones in Edge, and they pull out shopping there, which I thought was quite interesting. Obviously, you want all your money. Then you've got your security and Windows at the top, which is all your operating system ones as well. But there's loads there, isn't there? And there's more and more being added every day. And this is just Microsoft. Amazon, Google, IBM, they've all got loads of them. There's startups, Pieces, for example, starting up. It's all these co-pilots that are being sort of pulled in and being used as AI to help us in our day-to-day lives. But I was just quite shocked at how many there was just from Microsoft. How about the other co-pilot, the real co-pilot, is what I say. Now, this is the person that sits in the right-hand seat in that picture I showed you earlier. So it's me as a captain. I sit in the left. Helicopters the other way around, but they're weird. So I sit in the left as a captain, and I fly with a co-pilot, which is somebody who has exactly the same license I have, exactly the same training as I have, It's just the fact that I've been doing it a bit longer because I'm old. And they may be, I was flying with someone a month ago that was just fresh out of flight school, only a few hundred hours, new to the airline. And, a few days later, I was flying with someone that's got 24 years experience. And just because of COVID and various things that happened and various airlines have gone bust, they're now flying with us. But they've only been with the company a couple of years, but they've got 24 years experience, similar to me. I'm 26 years in now of flying. So that's the degree of what you can have as a co-pilot. So think of that as the fact that that co-pilot could be a junior dev, i.e. the person who's just passed their training, all the way up to quite a mid-level, senior level person. And there's the captain is like the architect within the team, the person that's orchestrating what's going on, making sure that everything's pulled together correctly, the one that makes a final decision. Are we going to go? Are we going to stay? What are we going to do when something's happening and going wrong? There's quite a lot of weight on your shoulders because you're well aware the other side of that flight deck door that's locked and bulletproof is potentially 180 people that want to make sure they get to their meeting or get to the beach. So you are kind of, you have that in the back of your mind when things go wrong. And they do from time to time, and hopefully you never hear about it because we've managed to sort it out and solve it. But the real co-pilot, unlike an AI co-pilot, which is a couple of years of training, a couple of $1 million, and they train it on the internet and all our open source GitHub repos, etc. A real co-pilot and a real pilot, like myself, we go into a simulator. This is a picture of one of our simulators at a training facility at Heathrow. And we go in every 6 months and we do 2 days of checks. So before we walk across the drawbridge, as we'll call it, and the moat of death below, we hand our license, our flying license, across the training department, and we say, there you go. And hopefully after the 2 days, they sign in a little box and give it back to you. You can go back to being a pilot again. If you fail to check, they don't sign the box. You don't go back to the line. You don't fly in passengers. You get handed across the training department, and the training department then train you back to standards. You then redo the check, but it's a different check this time. And if you pass that, then you can go back to the line. But then you're monitored, and you won't come back in 6 months. You come back in 3 months. So again, the training that is done in aviation is always to make sure. So every 6 months, I hand my career, my job, my life, across to the training department, which for some is quite stressful. You can imagine, like, you get taken into a room at work. And it's like, right, solve that coding problem. You've got 2 hours, go. You don't pass it, you don't solve it, out. It's not, it's like being interviewed every 6 months. It can be quite stressful. But it does mean that the level of training that is given to pilots, certainly in the Western world anyway, is second to none. Also, annually, we go and spend a day with our cabin crew colleagues, do security emergency procedures. So that's opening emergency doors, jumping down slides, putting a fire out, all those things that you don't think about that could happen on board an aircraft, donning oxygen masks and stuff like that and fighting a fire. Talking about, if there was the bomb found on board, what are the procedures behind that, et cetera, et cetera. We then have to pass 5 written exams. They're computer-based now. You just click yes, no, and stuff like that. 2-hour medical exam with a doctor. That's always fun, not. They do probe you in places where you don't want to be probed. Not good. Flight check. So once a year, we go with a normal flight with normal fare-paying passengers, but you have a checker sitting on the seat behind you. Doesn't say much and sits over their clipboard and just looking over your shoulder and just checking that you're doing things right. And then they sort of, again, it's a pass-fail thing. If you fail it, you're off the line, hand it back to training, go back into simulators, train back to standard, and the whole process starts again. And then once a year, we have a technical exam of 50 questions, which delve really, really deep into those corners of the ops manuals that you don't really look at that often. But our manuals are, when they used to be paper, when I started, you could stack them up like this. It's now all on an iPad, so it's in there somewhere. You just got to find it. So yeah, that's what a pilot has to go through training-wise, kind of throughout the year. So we're trained quite high kind of degrees and skill levels, but as an AI, they train it on the data that's out there, and they draw a line in the sand. We're continuously trained and looked at. But the reason we're trained is to deal with situations like this. So when you think, when I show these incidents, and this is where I'm getting to the point where I'm showing incidents and accidents, is think about what could we do with AI that we have today, or what might be coming in the future. Vision AI, natural language processing, ChatGPT can be used in places as well. What would you think we could use AI to help with this problem? Just think about that, and then we'll come up to how we're going to solve it later. So this is an accident, or an incident, wasn't an accident, that happens back in 2007 at Manchester Airport. There's Flappy Birds. There was Flappy Birds, and that is what's called an engine surge.
Mayday, Mayday, Mayday. Thompson 253 Hotel, engine failure. We are continuing with northwesterly and then inbound towards Wallasey. Thompson 263 Hotel, roger. All runways available for landing. Surface wind 070 degrees at 5 knots.
Left the alarm at the end because it just got me. It's like, all that was going on. It's like, oh yeah, I've got to say about that. We train that so often. It's like second nature. So that, that is not something that we kind of, have to think about. It's just natural. We just do it. A bit like when you jump in your car, you're driving along, you've driven through the traffic lights, you can't remember if there's red, green, or orange, but you've done it. You've changed gear without thinking. That's one of those instances for us. You can hear the air traffic controller coming back nonchalantly, still eating his Twinkie and drinking his coffee. So yeah, all runways available, wind is, and on that day the wind was dead calm. So if they needed to do an immediate return because the engine had failed and the other one had failed, they could have come back and landed straight away. But they said what they were going to do, an engine failure. We're going to continue towards Wallasey, which is pretty much Liverpool, out of Manchester, and continue with the SID, so the air traffic control knows where they're going, how they're going to get there, and we'll come back with further instructions later. So they've told the air traffic controller what they're doing. The air traffic controller said, you can land on any runway, just let us know. And everything's really calm because we practice it again and again and again in the simulators during the checks. You see when the video started, the gear started going up. When the engine was going bang, the gear was going up and the engine stopped surging. So I just need to do my hair because the photographer's here. That is all part of the checklist. Now we have, so I've got to do my pose now. We have a checklist in our quick reference handbook, which is our QRH, which is our Bible, which is a big thick book with all the checklists that are in there. And in that, on the newer aircraft, this pops up on the screen in front of you, so you don't need to get the book out and find the right page. So on the A320, this all appears on the screen in front of us on the ECAM. On the 787s and 777s, it comes up on ICAS, which is another system, almost identical. But this is also written in the book, just in case the screen breaks. Because in aviation, we always have a backup. So if the screen was to break, or something's happened with the electrical system, that screen goes off, like a major electrical failure, EEC is what we call it, then you can get the book out and look at the book as well. You can see here, thrust lever to idle, so I'm going to pull the thrust lever to idle. I'm going to check the engine parameters and just see what they're doing. Are they still banging? Because the bird has bent a few blades and the fuel is in there and it's doing some weird things and the vanes haven't moved, etc., etc. If it's still banging, okay, well, it's still surging, it's still banging, it's not a happy engine. Let's shut it down. So master engine off. You can see it's just got affected engine there. So we don't do this on our own. It's like, well, I'll pull that back and I'll shut that one down. It's like, all right, we agree which engine it is. Which engine do you think it is? Don't ask a yes/no question because you'll get a yes/no answer. Ask, open questions, what we do in aviation. So which engine do you believe is the problem engine? Oh, I believe it's number 2. Why do you think that is? Well, because we've got an EGT that's out of the gauge. The N1, which is the speed of the rotor, is up and down. So, we ask reasons why. And then you can see here, we shut down the engine. If normal engine parameters, i.e. we pulled it back and it stopped surging, well, actually, let's see if it still works a bit. Can we keep the hydraulics and electrics running? Can we get a little bit of power out of it? Or we're going to shut it down, and then you can go down the checklist. You can see there, it's a dead short. It's quite a major thing. We just lost an engine, but the checklist is dead short, dead easy. It's memorable, even though this isn't a memory checklist. This isn't one we do from memory, and there's not a box around it. But you can see it's quite a short checklist. Now, this has been developed over many years of many bird strikes, of many engine failures, and it's kind of what we learn from accidents that have happened in the past. Who remembers this incident? 2009, there's movies been made about this one. This was 4 minutes from hitting the birds, a flock of Canada geese to land on the Hudson. It's, again, what would AI do in this case? Has anyone watched the movie, Sully? Yeah? I took many years before I actually finally watched it because I thought it's just going to be Hollywood just gypsying it up. But actually, given the juice, it was pretty close to what actually happens. It was pretty close to what happened in the courtrooms and the investigations. If we look a bit more into this, they took off at LaGuardia Airport. You can see they're climbing, they hit the Canada geese, and they're turning back. You can see that initially, it's like, can we get back to LaGuardia? Back here. And initially, they're looking across here and seeing all the big tall buildings across Manhattan. And it's like, that's not a good idea. Because already down at 1,600 feet, as you can see in the box, doing 215 knots, so they've got a bit of speed to lose. They could probably maintain altitude for, I don't know, 20, 30 seconds before they're again having to descend again. And they're like, that's not going to work. You can see they start turning back, and this is where Sully sees the big blue runway that was the Hudson, and decides, actually, the best way of making sure I don't hit anything and kill anyone is to land in the water and, you know, take their chances with the ducks. And that's what they did. If you remember the film, they talked about, why didn't you turn and go to Teterboro, which is up there? And they practiced this and practiced this and practiced this in the simulator. It's like they could have turned, but they did about 40 attempts in the simulator, knowing when it was going to go bang, knowing all the parameters that were going to happen, and they'd practice it and got it wrong, practice it and got it wrong, practice it. It's like, no, we made it to Teterboro. Okay, but how many times did you do it? So AI may have chosen, well, I need to land on a runway. I'm going to go back to LaGuardia. I'm going to go to Teterboro because that is my programming. That is what I know what to do. Would it have made the decision to land on the water, to land away from an airfield when there's one so close? Could it have done the maths a bit quicker than Sully could have done and said, actually, I've got this much energy, this is my energy state, this is what I've got, this is my weight, this is what the wind's doing. Actually, you know what? I can get to Teterboro and get back to LaGuardia. You know, it's something that is being looked at by, you know, specialists working in this field as, you know, can we trust this to happen? I fly light aircraft occasionally as a hobby, and in the newer avionics systems made by Garmin, there's a system on board there that actually, if you lose the engine, I've only got one engine on a light aircraft, whizzing the hairdryer at the front, it then tells you if you can make it to an airfield, and it gives you directions to the nearest airfield that you can make. So it's starting to come, but that's on lower forms of aviation, and it will work its way up to the bigger jets in years to come. So it's starting to come, and again, that's using AI. It knows the state of the aircraft, the winds, etc., etc. So it's starting to come. How about this incident that happened at London Heathrow back in 2008, a year after the Sully incident? This is where it was Captain Pete Burkill and John Coward have flown back across Siberia. It's quite cold outside, air temperatures unseasonably cold, and basically the fuel froze in the fuel oil cooler fuel heater system on board the 777. They were 2 miles, 720 feet, about the right position when they realised the engines hadn't come up from approach idle, which is where the engines spooled up a little bit. So in case the runway's blocked or something happens and you need to climb away and do a go around, the engines are ready to go. Otherwise, it'd take about 15, 20 seconds to spool up. So they hadn't come up. They're starting to descend. Speed's bleeding off. It's like, what's going on? We've got an engine failure. What are we going to do? That's when Captain Pete Burkill puts out the Mayday, 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 Speedbird 38. It's on YouTube. You can watch it and listen to the tapes as well if you wish. But anyone knows Heathrow, is the A4. Clacton Cross Underground Stations is around here. There's a massive BP petrol garage just here. It is mid-morning, so rush hour traffic along the A4, lots of cars. And they've got an alien aircraft that's going down, and they can't go up. They're just going to land. I've spoken to Captain Pete Burkill about this, and he was thinking that they were going to hit the petrol garage or the A4, and he was trying to work out what to do. So, you know, it was quite, you know, he's got 30 seconds to make a decision. You know, a couple hundred people sitting behind him, he's got to make a decision. Go, what are you going to do? What would AI do? In this case, he, you know, phenomenally cleverly thought of the fact that when we go around, the first thing we do is set full power. The second thing we do is reduce the flaps, which are those big panels that sit out the back. And the idea behind that is reduce the flaps, reduce the drag. Yeah, and when you do that, and when you've done it a million times in the simulator like we always do, yeah, the aircraft gets this little kind of bump, only about 20 or 30 feet, but a little bump in the air as the flaps reduce and the airflow changes over the wing. He wanted that 20 or 30 feet of a bump. And that 20 or 30 feet of a bump cleared the A4, cleared the petrol garage, and got him to the grass because he did that. But he said his hand hovered over that lever for a few seconds, and he was like, yeah. And he did it. But if he hadn't have done that, they would have hit the A4. This would have been a much bigger, there would have been deaths and things. All that happened here, I think there was a broken leg, a broken arm, and some rash burns off the slides, mainly because people took their bags and they've been idiots. If you have an accident and you have to get off an aircraft, Leave it all behind. Do you really need your toothpaste? Do you really need your toothbrush? You know, and that jumper that you spilt your beer down last night anyway. Just leave it behind. You know, your life and all the passions behind you. You may be the first person off with your bag trying to get out the door. Just leave it all behind. They can go back and get it later. And that's what they did in this case, except for the people that were on the ground. I think if you take your bag off, you should be taken to court and, you know, be, I don't know, charged with something to stop people doing it, because the number of people that get injured because they take their bag with them, and it's normally the person that's carrying their own bag. But yeah, would AI have chosen to move the flap lever, do you think? Would it have made that calculation? Would it have known from years and years of training in the simulator and doing go-arounds in real life when it's windy, like the other week with Storm Ewan? I did one at Heathrow. Would it have known to do that? Probably not, because it hasn't got that learned experience. So, you know, these are the sorts of things where, you know, the aviation industry is moving towards AI, hoping to remove us pilots and the warm fleshy bits at the front, hoping to make it pilotless at the front. You know, but would AI have made that decision? The next thing I'm always asked about is obviously the MCAS on the 737 MAX. So this was the Lion Air Flight 610 incident that killed, I've got the number here somewhere, 189 passengers. And then 5 months later, literally just 5 months later, it was Ethiopian Airlines 302 out of Addis Ababa. And again, that killed 157 people on board. So quite a lot of people lost their lives because Boeing had this system called MCAS. It's quite interesting when you look into this and dig into this, and all pilots the world over have looked in, Boeing pilots or Airbus pilots like myself have looked into this. But they had a system that, because the engines were so big, they needed to, and the 737 design was so old, and they didn't want to update the 737 purely because they would have to go through all that process again for all the systems. Remember that SCADA I mentioned earlier, and sort of approve all the computers. Again, they didn't want to go through all that because a lot of money, a lot of development time. Airbus were winning on the market with the Airbus A320 family and the new Neo that had just come out. So it's like, we'll put bigger engines on, it'll be more fuel efficient, and carry more passengers, make it a touch longer. But it's still a 1960s aircraft under the skin, 1960s design. They didn't want to redesign it or touch it. So to get around the fact that the power couple of the engines and where they were, and obviously what was going on with the dynamics of the engine and the airframe, they come up with a system called MCAS, that if the aircraft was in a steep climb because the pilots had put full power on and the pitch power couple had just pitched it up like that, and the autopilot wasn't disconnected, they were worried that the pilot wouldn't react and put the nose down. Yeah, or the nose, because it's a Boeing. So they come up with this MCAS system that says, and you can see at the top left there, the angle of attack is high, which is pointing straight up. The autopilot is off, i.e. the pilot's doing it, not the autopilot. Yeah, and the flaps are up or coming up, they're moving towards up. Yeah, and it's in a bank turn, which is really dangerous because your lift vector is into the turn, not keeping the aircraft weight up. It's now part of it is into the turn. Then we're going to have this system that just puts the nose down. Yeah, and everyone was like, yeah, that's fun. You know, what's wrong with that? What could possibly go wrong? But they wired it up to one angle of attack sensor. One sensor was detecting the high angle of attack. Yeah, there's two on board an aircraft. There's actually three, I think, on the Boeing. There is three on the Airbus. There might be two, I can't remember. And in that, because they only wired up to one sensor, on that day, that sensor failed, or it was giving out a dodgy output, which is what had happened on both those aircraft. And because that one sensor had failed, it thought it was at a higher angle of attack, so it started pushing the aircraft forward. And the Lion Air pilots didn't stand a chance because they weren't told this system even existed. It was not in the manuals, there was no training. Because if they put a system on that has to be trained, it can't be used until all the pilots have done that training in the simulator. And Boeing decided they weren't going to do that because that's cost to the airlines, and they won't buy the aircraft because they've got to train all their pilots. So it pushed the nose forward, and they couldn't because the autopilot that was doing this and the system that was doing this had overall control of the pitch of the aircraft, they couldn't control it. They couldn't fight that control because they're pulling on the yoke, but there's a bigger computer back there that's saying, no, we're going to put the nose down. And they flew into the ground. Between the Lion Air and the Ethiopian incident, that 5 months, briefings went out once they worked out what had gone wrong to all the pilots that flew 737 MAXs and said, if this happens, this is what you do. This is the procedure. It was that procedure, you know, like I showed you in the QRH, that went out to all pilots. It's like, this is what you do if this happens. It's not going to happen. It's a one-off. We're going to fix it. Don't worry. And then they fought, and they used the procedure verbatim Not once, not twice, but many, many times they tried to use this procedure. But obviously the computer overruled them, and because the system hadn't been redesigned, and that's why they all got grounded fairly quickly. So that was an incident I'm often asked about. Yeah, you can see it can move. It's got quite a lot of authority of putting the nose down 2.5 degrees in less than 10 seconds. So that's quite a bump forwards that you're going to experience there. The passengers would have known what was going on there as well. What about in situations like this? Foggy conditions. Yeah, this is a recording of an auto land. This is where, when it's foggy and we're going to land the aircraft, we can't see out the windows. We can't see the runway. So we trust the autopilots to do this. So on the Airbus 320, there's 2 autopilots, left and right. They're going to, 1 and 2 on the Airbus. They're going to fly this auto land, and hopefully when you look out the window and you see that one light whizzing past, it's not a light on the A4 or the M4, it's a light of the Heathrow runway. But you can see here, 300 foot above the ground. 200 foot above the ground. See nothing. Same retard. I love this. I got this from YouTube, but I couldn't get the link, but it's got airplane TV up there. Don't try it without the required equipment, aircraft and airport training authorization. So they're covering their bases there. Don't do this at home, basically. That there wasn't actually a full auto land. We can go to a much thicker fog, denser fog, down to like 75 meters, even less, where we'd only see 1 or 2 lights. So they said, oh, approach lights. That's quite good. Actually, that's not bad. I can see the approach lights. Normally, when you're doing these, and you're doing these in the sim in training, you won't see the approach lights. You'll see 1 light going past, and it's like, do I land? Do I let it land, or do I go around? And you've got literally a couple of seconds to make that decision. And you get used to seeing the lights and what they look like. So yeah, but so that is there being done by autopilots, and this has been done. I think it was a Lockheed aircraft was the first one to have auto lands, and there's quite a famous story of in a tech log written by an American Airlines pilot back in the early 80s. Auto land is not very good in this aircraft, and the engineer wrote on there, auto land not fitted. So we've got to make sure we've got the right equipment, the aircraft is fitted, it's all working, all the systems are working, and we have a checklist we go through in the cruise where it's safe and we've got a cup of coffee in our hand to make sure that we can auto land this aircraft. And then the airport systems have got to be there as well, protected. There isn't a 380 turning 90 degrees across the radio beams that we use, because that will bend the beams and it will put us 50 foot that way or that way, which is never good because the runway is only 60 meters wide. So that's an auto land where we might be using it. How about the systems you use on board? GPS, we all use it, don't we? We get our phone out, Google Maps, how to find your way back to the hotel, etc., etc. It's increasingly being jammed across the world, either being jammed or being spoofed. And spoofing is where they send the signal to the GPS that is saying you're really here, and rather than it thinking I'm exactly here, it will send the signal, it will put you over that way. I've seen it on the grounds where we was in one of the Greek islands, and the GPS was being spoofed in that area, and the aircraft thought it was in the middle of the Mediterranean, so 40 miles away. But we was on the ground, the engine would turn off, it was no biggie. If we're in the air, we just revert back to using the radio beacons on the ground and using alternate means of navigation. But if we look at this website, you can go out to this. This is, it's back over here now. This is live. So we all know Flight Radar 24, Plane Finder, etc. Those Raspberry Pis that are sitting in people's sheds, I've got one at home, are reporting what airplanes it sees. But if you plug in the GPS receiver, it sends the GPS data it's receiving as well. And you know exactly where that Raspberry Pi is because you tell Flight Radar 24 where it is. And then they can see, well, I'm getting this data from GPS. I know I'm here because that's where Cliff told me I am. Therefore, that error vector is this. And if they get more than a few % reporting that it's out, but you can see here, there's obviously something going on around here. You can see down in the Mediterranean as well. The map normally reports down along here, but a lot of these have been turned off recently. I'm not sure if that's something that's going on through Egypt at the moment. But you can see there, and if you go across and move the map across, you can normally see when, there must be asleep at the moment, but normally through the Mojave Desert, there's a load of GPS jamming going on there, which must be where there's some base of some kind, I don't know. But yeah, you can see all the GPS jamming that's going on around the world. It's an interesting map. So before we go flying down to like Eastern Mediterranean and places like Larnaca and stuff like that, we would look at this map during our briefing and have a quick look and say, okay, there's lots of GPS jamming, so we'll be aware of the procedures. We'll have a quick look and a read as we're going through as well. So, I don't accidentally chose the right one. Oh, there you go. Go back. So, right, now let's move on to where a co-pilot could use us and help us as well. So, I showed a slide there. So, GPS is being jammed, and all these radio beacons that we use as secondary navigation, certainly in Europe as well, at the moment, they all use a lot of power, a lot of electricity. Not very green. We're trying to be a green human race at the moment. So, a lot of the authorities are starting to turn those off. But as they're turning them off, the nasty people are jamming and spoofing GPS. So they're getting to the point now, it's like, well, do we turn these off or keep them going and pay the electricity bill and be, not very green for safety, or do we turn them off and trust the fact that GPS isn't being jammed across Europe, where it is increasingly being jammed? So some clever folks at Imperial College have come up with this big 20-foot ISO container, which is using quantum stuff. I don't really understand it, if I'm honest. It's been tested by the Royal Navy because the military start with those sorts of things. They start with GPS, didn't they, let's be honest? And they're hoping to prove this. It works really well, apparently, if you read the document. You head out to the Imperial College, Imperial University website, and it gives them as good, if not better, fidelity of their position on Earth, all using these quantum accelerometers. But it's an ISO container. It's a 20-foot big, massive ISO container with cryogenic freezing in there and all sorts. So they've got a lot of work to do to make it down small enough that we can stick it in our pocket in our phone, or even stick it in the avionics bay of an aircraft. It's coming. GPS started out as a big hulking bulk of mass, so it will get there, just how long it will take. What's in development? What is it that Airbus and Boeing are developing? They go slightly different ways at the moment. So you've got Airbus is going down the route of augmenting and making the pilot better at their job, making the pilot, giving them more information. Boeing are going down the route of, the pilots are expensive and they just want to sort of go and do stuff down route. Let's get rid of those and we'll just automate it and make an autonomous drone. Boeing are being pushed that way by the American authorities because it's more about the military and what they can do. So that's where their research budget is being spent, is more on let's remove the pilots and make it more autonomous. Airbus are leaning more towards let's help the pilots and put better systems in. So a lot of this is coming out of Airbus. The Boeing also being a military-esque kind of manufacturer, they don't put much of this out, so it's a bit difficult to find the data about it. But this here is ATOL, autonomous taxi takeoff and landing. So they've got two test pilots there. I want you to watch his left hand when we get to it in a second. So you can see it's looking there, runway centre line. The green line is what the computer's seeing. The yellow line is the track of the aircraft. So it's slightly to the right and it's correcting. You can see it's an Airbus A350 taking off. You can see the algorithm data, which is tracking all the markings on the runway. You'll see in a minute, he gets told to rotate. So he takes his hand off at V1, blue circle, and he goes to pull back because that's his natural reaction as a pilot. I pull back to rotate. And his mate has to say to him, whoa, no, don't touch it. The computer's doing it. He takes off, climbs away. That's quite impressive that it's done that. But all it's doing is, when it gets to a certain speed, it knows to pull back and rotate up towards 15 degrees. It's not hard. It's just an input that we put on the joystick, which I don't think is connected anyway. And climb away. I say that jokingly. It's a joke within Airbus pilots. Lots of things break on an aircraft. From hydraulics and electrics and everything else. I've never, ever known anyone to say that the side sticker's broken. So we joke that it's not connected because it can't be, because otherwise it would have broken at some point. But it's a bit of an in-joke that I've shared with you now and the rest of the world. Hi, those that are at home watching. So that's quite impressive that it's done that. But would it have then coped with a bird strike that we looked at the Thompson fly earlier, that then led into an emergency situation? Then they need to speak to air traffic control and tell them what they're doing. Would it have been able to make those decisions? Would it have been able to safely fly the aircraft around the corner and not have an incident and hit a mountain would it have known how to do all that? There was 2 highly trained test pilots in the front of the aircraft. There's a couple more behind them. But they were there to make sure that aircraft got safely. And I know it's testing and they have to go through that. But would it have been able to make all those decisions? Would it have known what to do? You can see they set the engine power. It is just a switch on an Airbus. They put the gear up. They moved the flaps. Yeah, we can get an autopilot and automate those systems. But what happens when you put the flaps up and they don't move? Now you've got all this dirty, great flap hanging out the back of the aircraft. You're chewing through your fuel. And you've now probably, you've limited your airborne time. Instead of a couple of hours to get to where you're going, you're down to maybe 30 or 40 minutes to get on the ground. Otherwise, you run out of fuel. So, all those things that we as pilots are trained to do and we practice in a simulator, would an AI, would a co-pilot be able to go through that and work it out? Looking at computer vision, this is another thing that Airbus are doing. It's part of their Dragonfly project, which is where they've put cameras around the front of the aircraft. And they're looking out there, and they're not only just looking at what's there, but they're categorising it. So you can see red is bad, that's the beluga, which is the bit that takes the wings around Europe for them. And it's categorised that as an aircraft because it's painted red. It's categorised the green areas as the grass, and the grey areas is where it can taxi. This is just being pushed back. You'll see the pushback tug disappear here shortly. So there's a beluga moving away, and off it goes to take. You see the pushback tug goes away there. So they're looking at computer vision. And the idea behind this is when we're in low-vis conditions, an IR camera can see what we can't. So they're looking at computer vision. So actually, you're going the wrong way. You might bump into that beluga. Yeah, this is amazing stuff. We put a head-up display in front of us and superimpose that on the head-up display, or put it down on the screen in front of us. We can then decide, are we going the right way? Are we going to bump into something? That's amazing stuff that's coming out of that. The next bit they're looking at doing is fellow fly, which is where you've seen birds when they fly, they're flying a chevron kind of, don't they, or echelon, and they fly along. That's because the bird in the front is doing the hard work. The ones behind, the further back in the line you get, the more or less work you're doing. So it can be 5 to 10% for that bird, sort of 7 to 12% for that bird, and it gets more and more because the vertices come off the wings as they flap, and off the wings of the aircraft, creating vertices like this. And as it comes round, if you're in the right place, that vertice comes up. The wind vector comes up and gives you lift. So if you're in exactly the right place, it will give you lift that you don't then need to burn fuel to create, to go faster. So they're looking at fellow fly. We have a 5-mile circle around us that no other airplane should be in. If it is, you need to get out there quick. So the fellow fly system is going to use camera and vision and aircraft talking to each other to get them to within a couple of miles of each other. So we can then, the preceding aircraft can take advantage of the forward aircraft, and they can cross places like the Atlantic, and the preceding aircraft can save fuel, which is saving the environment, etc., etc. So this is the sort of stuff that Airbus are looking into. I assume Boeing are doing the same, but they're not putting the data out, whereas Airbus are. How about natural language processing? Air traffic control talk to us all the time, and they talk to us about telling us where to go, taxi assistance. So this is a video they put out a few months back, talking about how they're going to listen to air traffic control. So air traffic control talk to us in what may seem a funny language, but to us it's natural. And they tell you, I want you to turn left, go down Bravo, and hold short runway 32 right. So this is the aircraft up there. So they're going to come down the taxiway and then take off. And it tells them what to do. So they've told us as humans, but the computer has listened to it, transcribed it, and says, oh, I need to go that way. So it's going to draw it on our charts as well. So we can then see, well, that's the way we're meant to go. Add in that computer vision as well that we showed the previous video. And now you've got computer vision, GPS or ground-based systems that are going to say that you're taxiing along the wrong taxiway, which is never a good thing. Here's a taxiway though. And again, looking at a natural language processor, this is London Heathrow chart. You've got Alpha, which is this taxiway here, goes up and around, and it basically does a circle around Heathrow. Bravo is the inner one, and that does a circle as well. So we stick our little aircraft. I'm great at doing art. This is my primary school art lesson over. So we've got our little yellow aircraft there in the Yankee cul-de-sac, and we're told by air traffic control to Alpha, hold short Echo, runway 27 left in use. So that's what they're going to tell us to do. Yeah. Well, Echo is this taxiway here. So you can see the problem. It's like Alpha, well, would you go that way? Or would you go that way? Which way are we going to go to hold short Echo? Is the AI going to get that context? For us, they said 27 left is in use, which is this runway down here. So we know we're taxiing out, so we're going to come this way and hold short echo. We're going to stop there. But would AI know that or go that way and come against all the aircraft that are taxiing in from the landing runway of 27 right? So it's getting that context and getting that learning. I talked about Boeing as well and what they're up to. They're not putting much out there, but what they are putting out is what they're doing for the maintenance organisations. So this is a wing of an A320 aircraft. You can see they're looking at using camera vision systems to detect corrosion that's on the wing. This is one that's in deep maintenance, so it's having like a massive annual check called a C check. You can see all these areas which have been ground down through the paint because there's been kind of corrosion that's found underneath. It's not major, but it's corrosion that's been found, and you want to fix it and get it resolved and fixed and done before you release the aircraft back into service, and it will come back in for heavy maintenance 3 months later. So do we think an AI co-pilot could be a co-pilot? Do we think that all these systems, these computer vision, natural language processing, all these GPS data, do you think it could replace a co-pilot? Hands up, anyone? Yeah, there's a few people. Yeah, okay. In the long future, Denny's saying. Yeah, I got 15 years left in my career, Denny, so they can take their time. As long as they give me 15 years, I don't care.
I don't think it can be 15 years.
Yeah, so I agree. I think I think all the camera vision stuff will come in the next versions of aircraft. I think the natural language processing will come in probably a bit quicker because that just goes to our EFB systems. I think that will start to happen, and it will start to reduce the load. Airbus want to reduce it down to a single pilot in the cruise. Boeing want to get rid of us. You might have seen, it was in the media about 6 months ago, that Airbus were designing a toilet with a radio system inside in the flight deck. So if it was one pilot in the cruise and he got a bit caught out, he'd go to the toilet and still have the headset on and talk to air traffic control. I'm not sure about that. 1 minute. I'm not sure that's quite what we're looking for. But you've flown in, you've all been on planes, you've all flown on planes. Some of you might not like it, but you enjoy it, and you go on a plane, you go on holiday, you come to conferences like NDC London and the rest of them around the world. But if you got on board a plane and there wasn't a pilot sitting in the front, and you just had Otto the autopilot.
There it is.
There to save the day.
I'll go back to the passengers.
Going back to the passengers, if you was one of those passengers, hands up, would you still want to be on that aircraft? Would you still buy a ticket? You was all saying hands up for AI a minute ago. Now no one wants to have a go. But not both pilots being. But Otto's AI co, he was the original back in the 80s. Yeah. So that is kind of where we're leading, where we're going with aviation. And I'm taking both worlds as a developer. I'm really, really interested in this. As a pilot, I'm interested because I don't want them to take my career away because I love flying around the world. But mixing the two together, I'm giving this talk. First time I've given this talk. In aviation, we always have a post-flight review after every single landing. The last item on the checklist before we grab our bags, our wallets, and don't forget our coffee mug, and we disappear off behind the last passenger to go home. We always have a post-flight review. It's always at the bottom. Yeah. What did we do well? What would we do differently next time? Yeah, and is something I could do better as a pilot next time? They're the three questions we ask each other. It's always asked. When I go and work with teams on team skills in larger businesses, I'm invited in. I always encourage people, when you get to the end of a project, when you get to the end of a sprint, when you get to the end of an outage of some kind, if you're in the DevOps kind of world, when Black Friday's brought your computers down and all that sort of stuff, yeah, always have a post-flight review. What do we do well? What can we do better? And it's completely open, completely honest. Yeah, I've had co-pilots say to me, actually, Cliff, you did that really badly wrong. Oh, yeah, okay, yeah, I'll take that on board, yeah. And we're, really, really critical of ourselves. But I've been in times where I thought to myself, I really could have done that better. That wasn't my A game today. And my colleague, sort of kept us well, kept us, going the right way. So we always do a post-flight review. I strongly recommend you bring that as a simple thing to bring to your teams. When you do your end of your sprint and you're doing that wash-up meeting and you're talking about what went well, what went bad, just say, what did we do well? What could we do better next time? Yeah. And is there something I could be doing better to make me a better developer, me a better person, me a better pilot? Yeah. And you'll get, and just ask openly, give me the honest feedback. Yeah, there's green, yellow and red cards out there. It's the first time I've given the talk. It'd be nice to know what you think. Come and speak to me afterwards. And yeah, if you want to give me some feedback on what I could do differently and better in this talk, it'd be great as well. Also, as an MVP, there's the Microsoft stand outside. You can go and speak to a specialist if you want to have a private meeting about someone that is in your tech area. You don't want to do it in the middle of a conference floor. You can set one of those up as well. And go get .NET 9, do some Maui stuff rather than Xamarin. And I'm going to be around for the next 2 days. Great to see you all. Thank you very much.